Hi everyone, in this video I am going to talk about solving a rational inequality like this one right here. Alright, so if I have a rational inequality like this one, I need to use addition or subtraction to rewrite the inequality so all of the non-zero terms are on one side of the inequality, and so I usually would want the zero on the right side. So what I'm going to do is I am going to just subtract this x over x plus 4 from both sides like this, and then I will go ahead and actually find a common denominator. But one thing that might make that easier to do is if I factor this denominator right here. So 2x squared plus 5x minus 12, that factors into 2x minus 3 times x plus 4, then minus x over x plus 4 less than or equal to 0. Now, why that makes that easier is because now I see that both denominators have a factor of x plus 4, so I only need to multiply the x over x plus 4 by 2x minus 3 over 2x minus 3, so that this denominator is the same as this one. So I'm just building up this expression so that the denominator here is the same as the denominator over here. Then I can go ahead and rewrite this all over then. 2x minus 3 times x plus 4. And let's distribute this opposite of x here. So I have 2x squared minus 2x squared. Then that's plus 3x. And that's good because now the 2x squareds zero out. So I have 3x over 2x minus 3, and then times x plus 4 less than or equal to 0. Now, here is where I'm going to do a not necessarily a trick, but just a theorem that most people don't use. So what you should know is that if you have one expression over another expression, let's say less than or equal to 0, then this has the same solution as, if I multiply the numerator and denominator together. Right, so these two have the same solution. So that is a theorem that I am going to use to make this a little bit easier for me to solve here. All right, now, what does this tell me then? That means that 3x over 2x minus 3 times x plus 4 less than or equal to 0 has the same solution as, all right, and this is, by the way, when the denominator is not equal to 0. So just remember that we still don't want the denominator to be equal to 0. All right, as 3x times 2x minus 3 times x plus 4 less than or equal to 0, when the 2x minus 3 times x plus 4 is not equal to 0, or when the denominator does not equal to 0. All right, so now what am I going to do with this here then? So I have 3x and 2x minus 3 and x plus 4 less than or equal to 0. So that's what I'm actually going to work with here. All right, now I'm going to first of all figure out when this one equals 0 and this factor, and it equals 0 when x is 0. And then when does this factor right here equal 0? Well, it equals 0 when x is 3 over 2. And when does this factor equal 0? will equal 0 when x is negative 4. All right, now I know that, right, that this one can equal 0, but these two cannot equal 0 because these were the two that were in the denominator originally. All right, so keep that in mind. Now, I'm going to just sketch a little bit of a graph here. So here's where x is 0, and here's where x is negative 4, and here's where x is 3 halves, or 1.5. All right, now I just want to draw a little bit of a sketch of this graph. So I have 3x, 2x minus 3, and x plus 4, all right? And then I have my x value. So if I want to sketch the graph, I would do something very similar to what I normally would. So I have 3 times, so I could pick like a x is negative 5 over here and see what I would get. So negative 5 times 3 times 2 times negative 5 minus 3, and then times negative 5 plus 4. So again, 3 times negative 5, 2 times negative 5 minus 3, and then negative 5 plus 4. That's negative 195. All right, so I know that way down here at negative 195, there's a point on the graph, all right? This isn't to scale by any means. Now, let's just pick like another number, maybe like negative 2, all right? So 3 times negative 2, 2 times negative 2 minus 3, the negative 2 plus 4, that will give me, let's see what that gives me. So 2 times negative 2 times 3, 2 times negative 2 minus 3, and then negative 2 plus 4, that gives me 84. So way up here at 84 somewhere is where that point is. And then let's go with like x equals 1, somewhere right over here. So 3 times 1, 2 times 1 minus 3, and then 1 plus 4. So 3 times 1, and then 2 times 1 minus 3, and then 1 plus 4. That gives me negative 15. So negative 15, well, remember this isn't to scale right here, so negative 15, and then I need something over here, like let's just say that's 2, so let's go with 3, all right? 3 times 3, 2 times 3 minus 3, and then 3 plus 4, and so 3 times 3, and then we have 2 times 3 minus 3, and then 3 plus 4. That gives us 189. So way up here at, again, this isn't to scale, but 189 is up here somewhere. So 3, 189. And then I just draw a graph like in between these points. So it looks like this, and then down, and then it went back down here, and then back up. All right, so now that I know what the graph looks like, all right, think about this. This is where the dividing line is right here. This is where y is equal to 0. All right, all of the negative y values are down here. Negative y values, and up here are the positive y values. All right, so now what do I get from this? Well, if I want to know where this is less than or equal to 0, this means I want to know where the graph is going to go into negative territory. So where does the graph go into negative territory? Well, that would be right here and right here. All right, now, remember, way out on the end of your graph, you have negative infinity, and way out on this end of the graph, you have infinity. So Now we're going to write the interval notation for our solution here. All right. So remember that this was less than or equal to 0. So I know that between negative infinity and -4, the graph was negative. So that's where it was less than or equal to 0. So I have in interval notation negative infinity to -4, and I'm putting a bracket because of the equal sign here. Now, all right, now this is where you have to remember though, x could not equal -4. So even though this was less than or equal to, because x could not equal -4, I would actually change that to a parenthesis at -4 to indicate that x cannot equal -4. All right, now the same thing for this other portion where it is negative. This is negative between when x is 0 and 3/2. So 0 to 3/2. But because x could equal 0, I need a bracket there. But since x could not equal 3/2, I need a parenthesis here at the 3/2. So that means in interval notation, the solution is going to be, all right, negative infinity to -4. And then this will be, the other part it could be is, yeah, it could also be 0 to 3/2. All right, so there you go. That is how I would solve a rational inequality like this one. I hope that that was helpful, and thank you and have a great day.